Welcome to my case study circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of planes using the Solid Edge software. Coming to the problem statement. A rectangular lamina 35 mm cross 20 mm rests on HP on one of its shorter edges. The lamina is rotated about the edge on which it rests till it appears as a square in the top view. The edge on which it rests being parallel to both HP and VP, draw its projections and find the inclinations with respect to HP and VP. So looking at the problem statement, we can arrive at a set of conclusions. That is, initially a rectangular lamina, which is measuring 35 cross 20 mm, is resting on one of its shorter edges. That means what? Towards the right hand side of the observer, we should be having an edge measuring 20 mm. Next, the lamina is rotated about the edge on which it rests till it appears as a square in the top view. So this is with respect to the HP. So he tells that the top view of the rectangular lamina is a square when it is inclined with respect to the HP. So we do not know the angle of inclination with respect to the HP, but we do know that the top view is such a way that it is going to appear as a square. And also, with respect to the VP, there is no inclination given, but however, he tells that the edge being parallel to both HP and VP. So the edge on which it is resting, that means what? The edge which is measuring 20 mm is parallel to both HP in the first condition, and in the second condition it is also parallel to the VP. So this is what is the data given to us. So now we will see how to arrive at the solution for this problem statement. So now we will begin drawing the solution by constructing the xy line of any arbitrary length. So now we will go to the line option, select the line of thickness 0.18 mm and draw a line of any arbitrary length and annotate this line as xy. So the plane above the reference line is the vertical plane and the plane below the reference line is the horizontal plane. So now let us draw the rectangle. So the top view of the rectangle will be drawn using the visible line of thickness 0.50 mm. So the length is 35. The shorter edge measures 20 mm, so it is resting on one of its shorter edges. I will complete the rectangle. So now we will use the annotation to annotate the corners as A, B, C and D. So now we shall draw the front view of the rectangular lamina by selecting the projection line of thickness 0.13, intersect the XY line. So as per the given condition, the edge AB is the resting condition and also parallel to HP. And now the same edge shall also be parallel to the VP. So now we will see that when we are constructing the third position. So now before that, we will complete the front view of the initial position. So let us trim this portion of the XY line, select the line option and draw the front view of the rectangular lamina using the thick line. So now this completes the front view of the rectangular lamina. So now we will annotate. So the corner B dash is visible, so it is B dash, and A dash is not visible, so A dash inside the bracket. And here corner C dash is visible and D dash is not visible, so D dash inside the bracket. So this completes the first position. And now the second position is similar to the previous problem wherein it is going to appear as a square in the top view. So for that we will select the projection line, draw the horizontal projectors at any convenient distance towards the right hand side of the reference line and then draw the square which is the top view. So since it is visible, we will draw it using the thick line. So it should be a square. That means all the edges must measure 20 mm. And we will annotate this also. So this is corner A, this is corner B, this is corner C, and this is corner D. So now this data is given to us, that is it is appearing as a square in the top view. So now we will draw its front view. So to draw the front view, what we will do is we'll select the projection lines of thickness 0.13 and draw the projection lines to an arbitrary length vertically upwards, and then we are going to measure. So this will be 35. So use the smart dimension and measure the sides. So this is 35 cross 25 mm. So this is equal to 35. So now what we will do is we'll select the arc by center point and then draw the front view of the rectangular lamina. So keeping this as the point of center, that is the point of intersection, we will cut an arc of 35 mm length. Okay, so we will draw the front view from this point of intersection to the center point of the arc, so which is exactly 35, and we will trim this. And we will annotate the front view. So this is corner C dash inside the bracket D dash, and here this is the corner B dash inside the bracket A dash or A prime. Okay, so this is the front view of the rectangular lamina. So now in the second condition, this is given, but also with respect to the VP, what it tells is the edge on which it is resting is parallel to both HP and VP. So the edge on which it is resting is AB. And this is the second condition, which is which is being a square of 20 cross 20. With respect to the VP, the inclination is not given, but it tells that the edge on which it is resting is parallel to both HP and VP. So now what we will do is we will select this square and ensure that the edge AB becomes parallel to the vertical plane. So we will select this entire square and select the move option, ensure the copy is on. So move by keeping point A as the reference, correct? And now we will use the rotate option, ensure the copy is of first point of rotation, second point of rotation. So rotate until AB is parallel to the vertical plane. So we will just move this because we need to find the inclination with respect to the HP and VP. So we need to draw the profile view also to get that. So for that, we will, to complete the top view, okay, the top view is done. To complete the front view, we shall draw the horizontal projectors and the vertical projectors. So it is B here and intersecting C here, and then from D and A we are going to get this point, correct? So now we will draw the front view of the rectangular lamina. So by selecting a line of thickness 0.50 mm, we will complete the front view. So coming to the annotation, so this is corner A dash, and this is corner B dash, and this is corner C dash, and this is corner D dash. So this completes the front view of the rectangular lamina. So you can just see that the edge AB is parallel to the horizontal plane and the edge A dash B dash is parallel to the vertical plane. So this completes the problem. But however, it is asking us to determine the inclinations with respect to HP and VP. So we know that the inclination with respect to the HP is 55 degrees. But to determine the inclination with respect to the VP, what we will do is we'll construct the side view. So for that, let us draw the x1 y1 line of thickness 0.18 mm. So which is again a perpendicular line, and then draw the median. So the angle should be minus 45 degrees. So from the top view, draw the projectors, intersect to the median line, and then complete this. So from here, draw a perpendicular line until it is intersecting with the projector from the front view, correct? So now the side view of the lamina will be a thin line, a thick line. So from this point to this point, correct? So we will annotate this. So this is obviously corner D dash and okay D double dash, and inside the bracket C double dash, and here this is the corner A double dash, and inside the bracket B double dash. So now the angle of inclination. So you know that this angle of inclination is the angle of inclination with respect to the HP, and this angle is going to give us the angle of inclination with respect to the VP. Okay, so this is the angle of inclination with respect to the VP. So with this, we complete the problem. So to sum up, we have got a rectangular lamina resting on one of its edges, which is going to appear as a square when inclined to the HP, and the same edge is also parallel to the VP, and we need to determine the inclinations of the lamina with respect to the HP and VP. So we'll just complete the problem by annotating this as x1 and this is y1, and also indicating the direction of the projection lines. We'll also show the angle of inclination of the median line, which is 45 degrees. So the angle of inclination with respect to the horizontal plane is 55 degrees, and that with the vertical plane is equal to 35 degrees. So with this, we complete the solution for the given problem statement. Thank you all for watching.